Um, Hello everyone, my name is Jose Alberto Martins Morales, and today I'm presenting my SwitchBench Benchmark submission. This is a little project that I made as a part of the Kaggle competition, focus on evaluating executive function like behavior in large language models. So basically, this little talk will be about how LLMs handle rules switching, cognitive control, and structured decision making. So those are really important because actually they are the core components of human execute function. So let's start with this little presentation. So the agenda for this little presentation, it will be as follows. First, I will be a little introduction about the project. Later, we will talk a little more in depth. I will discuss what is the switch batch measurements. I will read later some method analysis. Obviously, I will present some helpful visual results and key findings that I found when created this little project. I will tell later what is the importance of this project, and finally I will close this little presentation. So let's start. So let's start with try to answer what is the switch bench. So basically, switch bench is designed to evaluate executive function, which includes the mental processes that allows us to plan, focus attention, switch between tasks, and manage competing information. So the key components of these measurements are executive function. The benchmark evaluates core cognitive control process, things like flexibility, attention, and decision making. These are the same process humans rely on when switching between tasks or rules. The rule is switching, so it's a major component. The major component is the rule switching. So the benchmark measures how efficiently a model can switch between different task rules. Indeed, this captures cognitive flexibility, the ability to adapt when conditions change. So later, I apply what I will call the switch coach. In the switch base, also quantize the switch coach, which is the performance drop that occurs when switching rules compared to repeating the same rule. For example, in humans, which course reflects the mental effort required to reconfigure a task set. But in this case, in LLMs, it reveals how well the model can update its internal state. Later, I apply the inference control. So the inference control is another key measure, which is the ability to suppress irrelevant or conflicting information. So basically, this will tell us how distraction affects accuracy. And obviously, I will talk about error partners, which including rule-based and stimulus-based errors. These partners help us to understand where cognitive controls breaks down. Okay, so for the Kaggle competition, we work with a tier-level dataset containing accuracy and reaction time, like measurements for each model response. The dataset consists of a rule switch task where each tier includes the rule applied, the stimulus, the models per response, the accuracy, and the reaction time proxy. Cleaning. Before analysis are removed invalid trias and filtered out RTO layers to ensure the metrics reflected meaningful behavior. The analysis focus on condition comparison, accuracy and RT summaries, switch cost, inference cost, and error types. This allows me to evaluate the model's performance according to different connectivity demands. So, with this on hand, what are the key visual results? So, one of the most important visual results is the difficulty curve. Across all difficult levels, LLM accuracy stays consistently slow. What does it mean? This suggests that the model struggles not just with complexity switching conditions, but even with the simpler ones. So, in other words, the curve shows no meaningful improvement as difficulty decreases, which indicates that the model is not reliably applying the rules. So we can say that it may be guessing or failing to internalize the task structure. So what are the key findings? When analyzing error parties, several issues became clear. The model shows systematic errors. So 3 points to highlight are: some stimuli are always answered incorrectly, both rules perform near chains, and finally, even repeated trials, which should be easier, fail consistently. So as a result, this pattern suggests that the model is not forming a stable internal representation of the rules. Instead, it may be rely on shallow heuristics that break down under even mirror variations. So, why this is really important? Why this matters? These findings have important implications for LLMs. First, understanding cognitive behavior. The SwitchBench has revealed whether LLMs are truly following rules or simply suggesting based on surface patterns. Second, limits of cognitive control. The result highlights limitations in flexibility, memory, and inhibition, all essential components of executive function. Third, fading failure patterns. Traditional accuracy metrics often hide these failures. SwitchBench exposes them by analyzing tri-level behavior. Fourth, human model comparisons. These benchmarks allow us to compare LLM behavior to human cognitive processes, which is essential for understanding how models reason. And finally, better prompt design. These insights guide better prompt design and evaluate strategies for future models. What is the closing for this video presentation? So, in simple words, to close, SwitchBench provides a powerful lens for understanding how LLMs think or fail to think in structured cognitive tasks. It shows whether models follow rules or exposes limits in flexibility and inhibition, and release hidden feature patterns that traditional metrics miss. For the Kaggle competition, this analysis helped me build a more rigorous evaluation pipeline and understand the deeper cognitive limitation of current LLMs. So, thank you so much for your time. I'm sorry if you don't understand me because I don't have a good pronunciation in English, but anyways, If you had any doubts about this little presentation, about what was the reason to make this project, please write a comment in the comment section of the Kaggle competition, and it will be a pleasure to answer any question. And again, so sorry for my bad pronunciation, and thank you so much for your time, and I hope we can create something together in order to improve these models, these artificial intelligence models like ChatGPT, Gemini, and so on, in order to help us, no, in order to how can I say this? In order to help us to construct a better life. Okay, thank you.